Hi everyone, I hope you're okay. This is a continuation video, guys, from from the first video whereby I just tackled graphs with regards to vertical projectile motion. On the first video, guys, I answered the first three questions, and all of them were velocity time graphs. And then on this video, just focus on the last two questions, guys. Please, guys, if you haven't watched the first video, just click the link on the bio and go and watch the first video, and there are other videos before that one whereby I teach vertical projectile from scratch. So just stay tuned, guys, and just indulge. Before I even start, please do share this video, guys, to your peers. A thing or two that I'll mention here might help them prepare for an upcoming test, or an upcoming exam, or even help them elevate their knowledge with regards to vertical projectile motion. And also, please don't forget to like the video. Don't forget to comment. You can ask questions on the comment section. Maybe suggest alternative ways in solving the problem. And most importantly, please do help us grow the channel, guys, by just subscribing. Thank you. Okay. A ball of mass 0.5 kilograms is projected vertically downwards towards the ground from a height of 1.8 meters. It was projected at a velocity of 2 meters per second, and then we are told that the position time graph for the motion of the ball is shown below. Okay, the position time graph for the motion of the ball is shown below. This is the initial position, the position where the ball was projected. I'm going to reference it as position A. I'll say this is position A. Then I'll have position B when the ball reaches the ground. Position B, that's when the ball leaves the ground after the first bounce. Position D, that's when the ball reaches maximum height. Then position E, that's when the ball returns to the ground. Then position F, that's when the ball leaves the ground again. Position G, that's our second maximum height. And position H, that's when the ball returns to the ground. So this is how, guys, you analyze this graph over here. So the first thing they want us to calculate, they're asking us actually, what is the maximum vertical height reached by the ball after the second bounce? The first bounce was here and the second bounce is here. So the maximum height is the turning point. Point G is the second maximum height and D was the first maximum height. So they are asking about the maximum height at point G. That's 0.5 meters above the ground. So maximum height is just 0.5 meters. Okay, and then now they want us to calculate the magnitude of the time t1 indicated on the graph. Basically, they want us to find the time at which the ball reaches the ground. I'll just focus on path A to B now. From path A to B, my initial velocity. Oh, another thing, guys, remember that in projectile motion you need to choose a positive direction. But in this case, the examiner has chosen upward as positive. How do I know? Because my graph is facing down like this. Are you together? If my examiner wanted to choose downward as positive, the graph was supposed to be like this. The same thing, but it was going to be reflected on the x-axis. If your graph is drawn like this, for those who are doing mathematics, we say that the quadratic function has a smiling face. That simply means A is positive. In this case, G is positive. G will be positive if and only if downward is positive. All together. But in this case, A is a set graph. That means G is also less than 0. G is always less than 0 if and only if if and only if rather upwards is taken as positive. So in this case, the examiner has taken upwards as positive, even though he did not specify that we must take up as positive. But I'm going to follow him and take up as positive as well. Okay, so I was told that the ball was thrown vertically downwards at a velocity of 2 meters per second. The magnitude of the velocity is 2 meters per second. However, it was thrown downwards. So I'll have a negative sign over there. I don't know the final velocity. And also, I know the distance covered. That's 1.8 meters in the negative direction. Gravitational acceleration is a constant, 9.8 meters per second squared. And then I don't know how long it took for the ball to reach the ground. Okay, I can simply use the third equation to find the time. Né? But you guys by now you should know that I don't like using the third equation if my initial velocity is not 0. Why? Because I'll end up using quadratic equation, of which I always make mistakes whenever I use quadratic equation in physics. So I'll refrain from that. So what I will do is to go and find the final velocity, the velocity with which the ball reaches the ground at, and then go and find the time it took for the ball to reach the ground. So how can I find my final velocity? I know that Vf squared is equals to Vi squared plus 2g delta y. All I need to do is to substitute here. Yeah? Initial velocity is negative 2 squared plus 2 times negative 9.8. Delta y is negative 1.8. This is equals to Vf squared, right? So therefore, Vf, I'll just put everything under the square root. Negative 2 squared plus 2 times the negative 9.8 and the negative 1.8. Okay, this will give me 6.27 meters per second altogether. However, guys, please remember that this was a downward velocity. Yes, whenever you put square roots on both sides, your right hand side should say plus or minus. But since we've taken up as positive, that means this will be negative 6.27. Why? Because when the ball was approaching position B, it was moving downwards, and we said every downwards movement has to be negative. So now I do know the value of my final velocity. That's negative 6.27. I can therefore go and find the time it took the ball to reach the ground. I can simply use the first equation because I do know the final velocity. I know the initial velocity. Gravity is a constant. The only thing I don't know is the change in time. So the final velocity is negative 6.27. This is equals to negative 2 plus a negative 9.8 multiplied by delta t. Whenever I take the 2 to the other side, it will be positive, right? So I'll simply have negative 6.27 plus 2. I'll get negative 4.27 on the left hand side is equal to negative 9.8 times root delta t. So I'll just divide my answer with negative 9.8 just to find the time it took. So delta t is equals to 0.44 seconds. So it only took 0.44 seconds for the ball to reach the ground. 0.44 seconds for the ball to reach the ground. Okay. And then now they want us to calculate the velocity with which the ball rebounds from the ground during the first bounce. They want us to find the velocity of the ball at position C. At position C, are we together? Okay, what do you know about this entire part over here? I know that point C and E are symmetrical at point D. Are we together? Which simply means that the velocity with which the ball will leave the ground at is the same velocity with which the ball will return at the ground. Are we together? So the velocity at E, the magnitude of the velocity at E and the magnitude of the velocity at C are the same. The only difference is their direction. Are we together? So if I can find the velocity at E, by virtue I would have found the velocity of the ball at position C. Are you together? Because C is when the ball rebounds to the first maximum height. Are you together? So how can I do that? I'll focus on path D to E. For me to find the velocity at position E, the initial velocity at point D, the ball is at maximum height. At position E, final velocity, that's what I'm looking for. The height, the distance traveled from maximum height to the ground, that's 0.9 meters, 0.9 meters in the negative direction, downwards, remember. Gravity will be negative 9.8 meters per second squared. I don't know the time it took for the ball to reach maximum height. I mean to move from maximum height to the ground. You know? I'm looking for the velocity at position E. Remember that if I can find the velocity at E, that means I also know the velocity at C. The only difference will be the signs they have. Okay, for the velocity at E, I'm expecting to find a negative velocity. Why? Because when the ball was approaching E from position D, it was moving downwards. Okay, I'll simply say Vf squared is equals to Vi squared plus 2G delta Y. I'm choosing this equation because I don't want to use an equation that has something to do with time, because I don't know how long it takes for the ball to move from maximum height to the ground. So I'm looking for the final velocity. The initial velocity is 0 plus 2 negative 0.9. Vf, yes, I'll insert square roots on both sides. 0 squared plus 2 times negative 9.8 times negative 1.8. This will be equals to 5.94 meters per second. But remember that, guys, whenever you insert square roots on both sides, your right hand side should always say plus or minus. Since this was a downwards velocity, we are going to say negative 5.94. Are you together? Remember that now I do know the velocity of the ball at position E. That's negative 5.94 meters per second, which simply means that the velocity of the ball at position C is positive 5.94 meters per second. This is an upwards velocity, right? The plus here, the positive sign, really tells us that it's an upwards velocity. So if I know the velocity at E, I simply know the velocity at C, because the velocity with which the ball leaves the ground is the velocity with which the ball will come back to the ground again. So to answer this question, they wanted the velocity, right? So you simply say velocity is just 5.94 meters per second upwards. If they said they wanted the magnitude, you were not supposed to write upwards, né? But they wanted the velocity, you must write the direction as well. Okay, the ball is in contact with the ground for 0.2 seconds during the first bounce. Calculate the magnitude of the force exerted by the ground on the ball on the first bounce if the ball strikes the ground at 6.27. Okay, we did get that 6.27 over there. Remember that. Okay. Firstly, I want us to find the net resultant force exerted by the ground on the ball, now. Okay. So I'll simply say F net is equals to, F net delta T is equals to the change in momentum, and then F net is equals to the change in momentum, Vf minus Vi all over the change in time. The mass of the ball is 0.5 kilograms. 0.5 kilograms. The final velocity, the velocity with which the ball, in here guys, we are focusing at position B and C. Ne? I know the velocity at position C, I just calculated it to be equals to a positive 5.94, and then the velocity at position B, we did calculate it before, we got the same answer as 6.27, but it's a negative velocity. Negative 6.27 all over the time of contact of the ball on the ground, that's 0.2. So F net is basically equals to 0.5 multiplied by 5.94 minus a negative 6.27 all over 0.2. I'll simply get 30.525 newtons. This guys is the net resulting force that the ground will exert on the ball. Ne? However, they didn't want us to find the net resultant force. They wanted us to find the force exerted by the ground on the ball. Ne? Okay, when the ball is on the ground, the ground will try to push the ball upwards, and hence the easy bounce, and excuse me, and the ball will try to push the ground downwards. Ne? Remember that when body A exerts a force on body B will exert an equal but opposite force. So there will be an upwards force, I'll say F up. And then since the ball is in the universe, it will always experience a gravitational force. All right, together. So and now I do know the value of F net. F net will be equal to the upwards force plus the negative gravitational force. Remember that we said up is positive. So the upwards force has to be positive and our weight has to be negative, right? This will be 30.525 being equals to F up minus weight. The gravitational force, guys, is just mass multiplied by the gravitational acceleration. The mass of the object is 0.5 multiplied by 09.8. So I simply have 30525 is equals to FU minus 4.9. When I take the 4.9 to the other side, I'll simply find the upwards force to be 35.425, just 35.43 newtons. Alright, good. So the upwards force that the ground will exert on the ball is this one. The upwards force that the ground will exert on the force, upwards force is just 35.43 newtons. Okay. Now they want us to draw the velocity time graph. Remember they have taken up as positive, right? They want us to draw a velocity time graph for the motion of the ball from the time that it was projected to the time when it rebounds to 0.9 meters. When it rebounds to a height of 0.9 meters. So they want us to draw a graph from the start until the first maximum height. That's what they want us to do. Okay, let's just use this space over here. I'm also going to take up as positive, né? So this will be my velocity time graph, like this. It was thrown at a speed of -2 meters per second. It went vertically downwards until it was negative 6.27. It remained at the ground. No man, it reached the ground at 0.44 seconds, right? Remember that. And then it will bounce at the speed of what did we get? We got 5.94 meters per second. 5.94, and then it will go to maximum height. It will go to maximum height, né? And the time over there, the time the ball that was 0.46. It left the ground at 0.46 seconds. Remember that the time difference has to be 0.2. 0.2 has to be 0.64, man. Hey, right, 0.44 plus 0.2. Yeah, 0.64. Okay, what else did they want us to indicate? The time when the ball hits the ground, the velocity of the ball when it hits the ground, the velocity when it rebounds. Okay, we've indicated all of that. And then now we must just label our axes. There's velocity in meters per second on the y-axis, and then we have time in seconds, and then the heading is very important: velocity time graph. So that's how, guys, you're supposed to draw your velocity time graph, né? Okay, now let's move to the last question. We are told that a small ball is dropped from a height of 0.2. A small ball is dropped from a height of 2 meters and bounces a few times after landing on the cement floor. Ignore air friction. The position time graph below, not drawn to scale, represents the motion of the ball. Same thing we did initially, guys. We must reference the positions of the ball, né? Excuse me. This will be position A, position B, position C, D, E, F, G, and H. It's very important, you know. First question, they want us to define the term free fall. Free fall is when an object is moving under the influence of gravitational force only. Okay, 3.2.1, they want us to use the graph to find the time that the ball is in contact with the floor before the first bounce. Okay, they want us to find the time difference over here. You'll simply say 0.67 minus 0.64, and then the time will be 0.03 seconds. Okay, the time it takes the ball to reach maximum height after the first bounce. The time it takes the ball to reach maximum height after the first bounce. Remember that, guys, according to symmetry, the amount of time the ball takes to reach maximum height is the same amount of time the ball will take from maximum height to the ground. All together. So for me to find the time it takes for the ball to reach maximum height, I just need to find the average of these two. All together. I'll simply say 0.67 plus 1.90 all over 2. So it the time at position D, let me round off to 2 decimal places, né? Should I? Now, the time at position D is equals to 1.90. 285 seconds altogether. But I was not asked to find the time at position D. I was asked to find the time it takes for the ball to move from position C to go to position D altogether. All I need to do is to find the difference. To find the difference between time D minus the time at position C. That's 1.285 minus 0.67. Minus 0.67, yeah? 1.285 minus 0.67. I'll simply get to 0.615. Just round it off to 2 decimal places. The ball took 0.62 seconds for it to reach a maximum height. You can calculate it, guys, if you want, no? Can you? No, you don't know the velocity with which the ball leaves the ground. This was the only way, guys, you're supposed to calculate the time it took. Okay, now they want us to find the speed with which the ball leaves the ground after the first bounce. We are focusing on time C to D, ne? Part C to D, the initial velocity, that's what you're looking for. Velocity at maximum height, that's 0 meters per second. Gravitational acceleration. The examiner has also chosen downwards as negative, guys. Why? Because my graph is a set face. That means gravity is negative. Altogether. So if downwards is negative, that means up is positive, and my gravity will be negative like this. Delta Y, from part C to D, the ball is displaced upwards to a distance of 8.5 meters. The time it takes for the ball to reach that point, that maximum height, is 0.62 seconds. They want us to find initial velocity. I'll simply say Vf is equal to Vi plus G delta T. Final velocity is 0. I'm looking for this guy, and I'm expecting to find a positive value because it's an upwards velocity. That's negative 9.8 times 0.62. Negative 9.8 times 0.62. 0 is equals to Vi minus 6.076. So therefore Vi is just 6.076. Whenever I round it off to 2 decimal places, I'll simply have 6.08 meters per second upwards, né? But they said they wanted the speed, so I'll just write the magnitude, 6.08 meters per second. Okay, now they want us to find time t. Time t. Time t, ne? Time t, how can I find the t? Okay, let me just erase everything here. If I can find the velocity, what do I know? Let me check. I know that after the first bounce, it will take this thing. Okay, I can find the velocity at point H, né? How can I find the velocity at point H? I'll just focus on path GH. Excuse me. If you focus on path GH, né, from point G to H, initial velocities at point G, the ball was at maximum height, so 0.0 meters per second. final velocity. When the ball is at the ground, I don't know the velocity of the ball, and that's what I'm looking for, because it will help me to find the time at position H. Now, what else do I know? Gravity, that's 9.8 meters per second. It's negative because up was taken as positive. Displacement, this will travel from maximum height to the ground. The straight line change in position is 1.2 meters, but in the negative direction, and I don't know the time it takes. Oh, but I can simplify the time it takes here, guys. I must not complicate my life. If I can find the time it takes for it to reach to move from G to H, it will be much more easier. I'll show you how rather. Remember that delta y is just equals to vi delta t plus 1 over 2g delta t squared, right? My delta y is negative 1.2. Initial velocity is 0 multiplied by delta t plus 1 over 2 multiplied by delta t squared. Negative 1.2 is equals to 0 minus 4.9 delta t squared. So all I have to do is to divide both sides by let me simply do this. Delta t squared is just negative 1.2 all over negative 4.9. If I want to remove the squared, I must just put square roots on both sides. So I'll just say negative 1.2 divided by negative 4.9. I'll simply get 0.45 seconds. Are you together? So the ball took 0.5 seconds to move from maximum height, 0.45 seconds to move from maximum height. The amount of time it will take the ball to move from the ground to reach maximum height is the same amount of time the ball will move from maximum height to go back to the ground. So I also have 0.45 seconds here as well. So in total, I just have 0.9 seconds. Are you together? So for me to find the ball will travel for 0.9 seconds after it was in motion for 1.97 seconds. So time t will be equals to 1.97 plus 0.9 seconds. You'll simply get to 2.87 seconds. Let me confirm. 1.97 plus 0.9. Yeah, we'll get 2.87 seconds. So time t on the graph, t is just equals to 2.87 seconds. That's how, guys, we're supposed to answer these two questions over here. Just stay tuned, guys, and wait for more videos. Thank you for your time. Bye.